In the September 2nd issue of JACC, there's a state-of-the-art review translating stem cell research to cardiac disease therapies. Now, this is not perhaps this paper that you're thinking, because this is not just another rehash of stem cell therapies and aren't these great. This more involved pitfalls and prospects for improvement. It's kind of an explanation as to why it hasn't worked and maybe why it won't work. So I'm talking to a professor of cardiology. His name is Darrel Francis, and he is from the International Center for Circulatory Health, National Heart and Lung Institute at Imperial College in London. And your part of this article deals with noise, optimism, and denial. Okay, first, before we get into that, what were you guys trying to do with this particular state-of-the-art review in JACC?
Well, so this was an article, a state-of-the-art review, written by true experts in stem cell science, which I am not. The article was reviewed by different reviewers, and we had a situation where the reviewers disagreed on whether the article was correct. And so with the judgment of Solomon, the journal said, well, let's get the two reviewers who totally disagree with each other to write opposing editorials to add balance. In our article, we couldn't really talk about the science of stem cells because I don't really know anything about it to any level compared to the people who are writing on both sides of us.
Right.
So we looked at something that we're very interested in. My interest is delivering reliable science. And through this, I've learned to understand a lot about the things that we do that leads us inadvertently to give scientific findings that are incorrect. And this can be sometimes just harmful by wasting resources, but it can cause downstream harm in waste of resources by going down blind alleys. And it can actually harm patients, as some people will know that I've discussed in relation to something else. And in this article, we studied the three things that you need, that if you have them, you will probably get the wrong answer in your science. And the first is a thing that we all have in our clinical practice. We have noisy measurements. So when I measure your blood pressure, I measure it and then press the button again, get a different number, press the button again, get a different number. Likewise, if I measure your ejection fraction with an echo, I get one number. But if I bring you back another day or later the same day, we get a different number. And cardiologists are very used to dealing with this. And one of the ways we are trained to deal with this, I was trained, is to use the value that most fitting the overall picture of the patient so that it makes a nice, clean picture so that the patients can understand, other doctors can understand what you're supposed to be doing. There's a problem though. To do so requires taking other information into account. How does someone who is doing a clinical trial, who teaches that person that they should not do this? They should not use other information when they're doing a clinical trial. So, strictly speaking, clinical trial training teaches you this, but not everyone has this. And not every technician who's doing a scan, who is unblinded to knowing which treatment had the arm, which arm the patient is in, has this information, nor realizes why it's important. So, if you have a variable that is completely rock solid, that cannot change, say your date of birth, every time I assay your date of birth, I get the same value. Or I assess your age. It changes, but in a predictable manner. Other things like blood pressure and ejection fraction, which are the two examples we give, wobble about quite a bit. On top of that, that on its own is okay, as long as we measure them dispassionately and pick one of them by chance at random, or take an average of several.
But usually they're not dispassionate, they have optimism.
So once you have optimism, then you're in trouble. Because then you say to a patient, oh, this is working really well. And it's our job as doctors to give patients encouragement. It's actually our job. If we didn't do it, we'd be very poor doctors indeed. But doing so, one of them is to pick the most positive thing out of a set of results. And that's my job. I do it in my clinical practice, I admit it. But actually, I think that's right when I'm wearing my hat as a doctor. But when I'm wearing my hat as a researcher, I shouldn't do it. Yeah. So in the article, we show how if you have no noise, then having optimism doesn't do any harm. But once you have noise and the ability to select, the optimism causes you to pick a biased value. And you end up with a statistically significant result, which tells you that the values measured in the treated patients are better than the values treated in the control patients, But that doesn't tell you it's because the treatment works. It could be just that you're very optimistic or there's a lot of noise.
So how often is there a lot of noise and there's a lot of optimism? What percentage of trials are we talking about?
That's a very good question. So most people, when you ask them about the noise present in something like blood pressure and ejection fraction, vastly underestimate the amount of noise because we use the wrong measure of noise. We take one frame of video of echo and we get two guys to look at it. And if we're lucky, if we're being good, we make them blinded. But other times they have a little coffee and discuss, and then amazingly they say it's the same. That's the wrong measure. So think about this. If I was measuring the reproducibility of blood pressure, would this be valid? I put a blood pressure cuff on your arm, press go, value comes up, 128/76. I say, okay, and then I ask Jim over there, come on, have a look. What does it say on this screen? That would be ridiculous, but that's actually what we're doing with echo. We should collect another biological sample, we should do another scan, and when you do that, the noise is quite large. And I'm very keen to develop ways to reduce that noise, and we've got methods to do it. We're working on Imperial College. The optimism is, now the second question, optimism, you only have to read the opening words of every paper on some therapies. I shan't mention the name of which ones, and leave you to look yourself to see the level of optimism by the choice of words people give. Optimism is necessary sometimes to squeeze money out of funders. The trouble is that optimism, which we should be wearing a special optimistic suit for doing that, we should take that off and wear a neutral suit when we're doing the science, but it's very difficult and I can't do it either. The thing is, noise and optimism will give you a false positive result consistently. That is still okay if we realize that's going to happen, because then we would arrange for ourselves to be blinded. Then I'm equally optimistic on every patient because I don't know which patients had the real treatment. The trouble is, I have many friends in this field and also developed some people who one perhaps wouldn't call friends, but I have made and lost a lot of friends. And when you speak to them, they say, oh yes, very important, noise and optimism, absolutely terrible. And it affects the whole field. Not me, of course, because I'm honest. And so I call that the third element, which is denial, which is we accept that it exists, but we think A, that it is small, the effect, and B, it affects only other people.
But it's not necessarily honesty. Is that the mistake that these people are making in terms of it can be mathematically determined?
So they say they're honest in the sense that I'm not dishonest, I'm not setting out to give the wrong answer. But unfortunately, I've got a protocol that leads to, as a natural consequence of how the human mind works, getting the wrong answer.
So in terms of researchers, what should they be thinking to try and break this particular bad habit?
Okay, it's tough, and I don't know if it's suitable for Cardiosource, but I say this. Suppose your mother, or your close relative, your sister or brother, is dying of this disease. Imagine your close family member is dying of this disease, and you are doing the world-leading research that's going to fix this disease and save their life. But unfortunately, you're called away, and you have to go and do something, military service for a couple of years. And so the research is going to be done by another guy. Unfortunately, this is the guy where everything he does is positive. He's got mysterious green fingers. He's the biggest crook in the building, and nobody wants him in the group, and that's why he's doing your project when you're away. What would you do to the protocol to make sure that even the biggest crook cannot get the wrong answer? Work out what that is, and then think, good news, you're doing it yourself. But maybe you should actually follow what protocol you were going to apply to him. And that's what I tell my fellows, that they're always checking up on each other for cheating, and always making fun of each other for inadvertently cheating. And they're always thinking of ways to protect themselves against bias. But it's a mindset that we don't have to do in clinical medicine, because actually giving biased information is our job as a doctor, to keep people cheerful, to get people better. So we need to realize it's a different thing. We're trying to get genuine knowledge.
So this is it's a review paper that offers a couple of different points of view, but you're kind of in the middle going, here are some of the issues that we really need to deal with in stem cell research.
My point of view is that the true effect size of stem cells, when you look at the most reliably reported trials, the ones with the fewest sort of little discrepancies and mistakes, I have a controversial view, which is that those with the smallest number of mistakes might be the most reliable. And if you look at that, the ones with the fewest mistakes appear to have an effect that is 0 or almost 0. So in that context, it might be that almost all the effect that one sees is bias. And that might therefore make it an unusual example of a field where we can study the phenomenology of inadvertent bias in results.
Oh, wow.
But there's nothing special. As Professor Lemuel Moye of the States wrote a very kind and intelligent answer to our paper, he pointed out that this is very common in other fields too. It just so happens that the ratio between the amount of bias and the amount of genuine effect might be unusually high for this field. And so it's an unusually good model to examine this question in.
Well, this question is what's in the September 2nd issue of JACC. If you have not seen it, please go back. It's a state-of-the-art review, and it's on translating stem cell research to cardiac disease therapies, the pitfalls, and maybe some prospects for improvement. For Cardiol Source World News, I'm Executive Editor Rick McGuire.